We're going to work on problem 42 in 6.4. That's a partial fractions integral. It's got the integral of t to the fourth over t to the fourth minus 1 dt. That's on page 631. So there we have it. First thing you should notice is the degree of the top and the bottom, the numerator and denominator, are the same. So polynomial division is in order. We need to have it be a proper fraction before we apply partial fractions. So t to the fourth minus 1 divided by t to the fourth. It's a fairly easy problem to do polynomial division on. Notice the remainder is 1. What's that mean? That means this piece breaks apart as, the remainder's -1. I'm sorry. That means this problem really reduces to 1 plus -1 over t to the fourth minus 1 dt. Okay, so this integral is quite easy to do, and we're going to focus on this piece here. Well, I need to break that apart. It's 1 plus, and then I need to break apart this denominator. Let's see, t to the fourth minus 1, that's t squared plus 1 times t squared minus 1. Now, this is irreducible. That can't be factored, but this can. That can be factored as t plus 1, t minus 1. So I'll go ahead and do that. So we have one irreducible quadratic and two distinct linear terms. That means when I'm trying to come up with the coefficients, so I'm going to end up with something that looks like integrating 1 plus something over t squared plus 1 plus something over t plus 1 plus something over t minus 1 dt. And I'm going to move over to this side of the paper maybe and think about how to solve that. Well, I need all of this thing to equal -1. So I have -1 over t squared plus 1 times t plus 1 t minus 1. And if that's going to be equal to ax plus b, x squared plus 1, whoops, shouldn't be x's, should be t's. Keep the same variable, plus c over t plus 1. Remember, if it's an irreducible quadratic, we have a linear term in the numerator. Since this is a linear factor, it just has a constant, plus d t minus 1. I'm going to clear denominators, multiplying everything by t squared, t plus 1, t minus 1. Let's see, so that gives me -1 equals, here the t squared plus 1's cancel, and I get a t plus b times t plus 1 times t minus 1, that's t squared minus 1, plus c times the other two terms, t squared plus 1, t minus 1, plus d times the other two terms, t squared plus 1, t plus 1. Okay, now I have to exercise my sneaky picking so that I can make as much of that 0 as possible. Seems like t equal to 1 would get a lot of that stuff out of the way. So if I chose t equal to 1, -1 would be equal to, this is all 0, plus 0, plus, let's see, that's 2 times 2, 4d. So that means, I suppose, d equals -1/4. That's convenient. In fact, just to keep track of it, I'll write that in up here. My d is -1/4. Okay, what else would be nice here? Well, how about t equal to, say, 0? I know that would make that term 0. Maybe life would be fairly pleasant there. T equal to 0. Let's see, that gives me -1 equals, that's just b times -1, so that's -b. Let's see, here I have, if that's 0, I have 1 times -1, c, so that's -c. And then here I have -1/4 times 1 times 1, so that's -1/4. Not so bad. Now, I'm just really tempted to come up with something that will make those things 0. Well, what do I need that was squared would give me -1? Let's just play it risky and put in I. This still works for imaginary numbers, and what I would get is I'd get -1 equals a times ai, plus b I squared is -1, so -1 times -1 is -2, plus this term will give me 0, this term would give me 0. Well, that's quite interesting, because on the left-hand side, right, I have 0 i's and a -1. On the right-hand side, I have -2 i's minus 2 b's. So what's that mean? That means if this coefficient is supposed to equal 0, it means a equals 0, and I suppose that means b equals 1/2, because if that's 1/2, then that's equal to. Okay, so we have some nice stuff up here. That means right here I have no a's, so 0t plus 1/2. My only piece left is to figure out what c is. Well, I could do that from here now. Let's see, I could add in what b is there, so -1 equals -1/2 minus c minus 1/4. I guess I should add 1/4 and 1/2. That gives me -3/4. That means I need to add 3/4 to both sides, but if I add 3/4 to -1, it gives me -1/4 equals -c. So you can see that c equals 1/4. Okay, so assuming that I didn't make any typos, there we have it. Okay, so this is now the integral that I get to do. First piece, I really like that one. The integral of 1 in terms of t is t. The integral of this piece, the 1/2 is a constant. Now you notice that the t squared plus 1 in the denominator, that would be the derivative of tangent inverse. So this is tan inverse, or arctan t. This piece here, we have the constant 1/4. Then this piece, you could do a simple u substitution with the denominator as u. That would be natural log of absolute value of t plus 1 minus 1/4 natural log of the absolute value of t minus 1 plus c. So the integral, once you finish the partial fractions, the integral works quite well there.